In this lesson, we will be looking at putting equations into standard linear form. In standard linear form is ax plus by equals c. What that means is that you basically have to have anything with an x or a y in it on the left side of the equation. Your x comes first, then your y comes second, and then your constant comes on the right. So first of all, when you make your equation, you can only have integers. You cannot have fractions or decimals. This will all make so much more sense when we do it in a problem here. Your leading coefficient, basically that's your a. That's the one in front of your x. So the number that's in front of your x term cannot be negative. It has to be a positive number. And the other thing is your greatest common factor. So the number that goes into a and b and c has to be 1. And we'll do some examples to hopefully make this a little clearer for you. So first of all, I'm giving you an equation. First of all, I want to remind you from your last lesson that this is a linear equation because it has no more than 2 variables in it. There are no exponents, there's no variables in the denominator, and their variables are not multiplied together. So this is a linear equation, 3x plus 7 equals negative 2y. But it is not in standard form. In order to get it in standard form, I want the x's and the y's on the left and the constant on the right. So for this particular problem, I need to add the 2y, move it from the right side to the left side. So I'm going to move the 2y over there so that I have 3x plus 2y plus 7 equals 0. And then I need to move my constant, or my c term, that's the 7 in this case, over to the other side as well. So I will subtract 7, and I will have 3x plus 2y equals negative 7. Okay, so I need to check some things now in order to know if it's in standard form. So I already know it's linear, but now in order to check that it's in standard form, I cannot have any fractions or decimals, which I don't. My a, or my leading coefficient, which is the 3 in this case, can't be negative, which it's not. And then the number that goes into a and b and c, so 3, 2, and negative 7, has to be 1. That has to be the biggest number that goes into all of those, and in this case it is. So this is my equation in standard form. We'll do a couple more of these. Okay, again, this is a linear equation because I have no more than 2 variables. I do not have any exponents. I do not have variables in the denominator, and my variables are not multiplied together. So I know this is linear. However, I want to get it in standard form, which we know is this form right here, which means I have to have my x's and my y's on my left and my constant on the right. And so this is really close to standard form. But now to check if it's in standard form, some rules have to apply. So first of all, I can't have any fractions and decimals, which I don't. And my next rule I need to check is, does my leading coefficient, which is this term right here, it can't be negative. And it is in this case. I have a negative 3 there. So what I'm going to do is I'm going to multiply this whole thing by negative 1 and then switch the signs all the way across. So negative 1 times negative 3 would be, x would be positive 3x. Negative 1 times positive 2y would be negative 2y. Negative 1 times negative 25 would be positive 25. One of the most common mistakes people make is forgetting to multiply that right side by negative 1 and switching the sign over there as well. So here it is now in standard form. All right, now as we look at this one, again, I know that it's linear because I have no more than 2 variables. I have no exponents, which is good. I have no variables in the denominator, and I have no variables that are multiplied together. So I know this is linear. In order to get it in standard form, I need my x's and my y's both on the left side. So I need to move this 1/2 x over to the other side by subtracting it. And then I have negative 1/2 x plus y equals, those will drop, and then I have negative 3 over here on the right. Okay, so I'm getting closer to standard form because I have my x's and my y's on the left. But as I go through my rules, the first rule is that I cannot have fractions or decimals, which I do in this case. The second rule, the leading coefficient can't be negative. Here's the leading coefficient, and what do you know? It's negative. So I've already broken 2 rules, okay? So I'm going to deal with both of them at the same time. So first of all, that number that's in front of the x can't be negative and it can't be a fraction. So what I am going to do is I'm going to multiply everything by negative 2. Okay? I'm multiplying it by 2 to get rid of this number right here. And I'm multiplying it by negative so that I have a negative times a negative, which becomes a positive. Okay? So that's what I'm going to do. When I take this times this, these 2's are going to cancel. And I will have negative 1 times negative 1, which is positive 1x. Here I will do negative 2 times y, which would be negative 2y. And here I will do negative 2 times negative 3, which is positive 6. And now when I do this, I have no decimals, no fractions. My GCF is 1, and I have a leading coefficient that's positive. So I have met all the requirements. All right, a couple more here. Again, here you have a linear equation because I have no more than 2 variables. I don't have any exponents in here. I don't have variables that are multiplied together, and I do not have variables in the denominator. So I know this is linear. However, it is not in standard form. So to get us started in standard form, I'm going to add this x over to the other side so that I can get my x's and my y's all on the right side, or all on the left side in this case. And then I will have 3/5 x plus y equals 1/4. Okay, so now you can't have fractions or decimals. So basically that's a problem because now I have 2 fractions I have to get rid of. I have to get rid of this 5 and I have to get rid of this 4. Okay, can't have fractions, so I need to get rid of those denominators. They are different denominators, and so what I would do is think about this. If you were going to get rid of this denominator right here, you would multiply by 5. And if you were going to get rid of this denominator right here, you would multiply by 4. So now think about this. Instead of multiplying by 5 and then multiplying by 4, you can take that fraction, or the whole equation instead, and multiply by 20. Okay? So look at what your common denominator would be on all your fractions. In this case, I have a 5 and a 4, so my common denominator is 20, and I'm going to multiply the whole equation through by 20. Okay? So when I do 20 times 3/5 x, I'll do this off to the side so this isn't so confusing. 20 times 3/5. The 5 will cancel, that will become a 4, and I'll have 4 times 3, which is 12. Okay? So 20 times 3/5 x would be 12x. 20 times y will be 20y. 20 times 1/4. Okay, I'll do this off to the side too. 20 times 1/4, that will cancel and become a 1 and a 5. So 20 times 1/4 is 5 times 1, which is 5. Okay, now if I look at this, I want to look at my leading coefficients. So I have 12, 20, and 5, and I want to make sure that there is not a number that goes into all 3 of those other than 1, and there is not here. So this would be my answer in standard form. All right, this one is a little tricky because it looks like you have more than one variable there, but you do not. You need to notice that your 3x and your 2x and your 4x can be combined to make 6x, so that might make that easier right off the bat. This 2 is linear because you only have 2 variables. You have no exponents, no variables multiplied together, and no variables in the denominator. So I know it is linear, but it is not in standard form. So to get it in standard form, I will subtract the 6x so that I get my x's and my y's on the left side. And I have negative 6x plus 3y equals, I have nothing left on the right-hand side, so it'll be 0. And again, your leading coefficient cannot be negative. So I can't have this number be negative, so I will multiply everything through by negative 1, which basically switches all the signs. So negative 1 times negative 6x is positive 6x. Negative 1 times 3y is negative 3y. Negative 1 times 0 is still 0. And this would be my equation in standard form. And lastly, sometimes you only have one variable in there. That's okay. I only have an x. I do not have any y's. I still need all my constants on the right-hand side. So I will subtract 8, and I will have x equals negative 11. So if you think about this in standard form, this is what this really is. There's an imaginary 1 right here. So what this really is 1x plus 0y, because I don't have any y's, equals negative 11. Okay, now you're not going to write the 1, nor are you going to write the 0x, but you can see why this is still in standard form. Okay? Then, I want to tell you this too. Sometimes you'll get down to an equation that looks like this. 3x plus 6y equals 12. Okay? If I look at 3, 6, and 12, those are all divisible by 3. Okay, so I want to divide them all by 3. So I will divide these all by 3 and get x plus 2y equals 4. If I left it as it was in red, it would not be in standard form because my GCF for my coefficients is not 1. Now if I look at this, my GCF for my coefficients, I have a 1 that's not written right here, a 2, and a 4. And the only number that goes into 1, 2, and 4 is 1. So my GCF is 1.